Good evening to everyone,
Good evening.
and welcome to this Mowito Presents CXO Roundtable. And this Think Tough Roundtable is on a very interesting topic, adaptive manufacturing from fixed system to flexible intelligence. This is the theme of the event. This is the second in series of such CXO roundtables, and this is virtual in nature because all of us are in different parts of the country, as well as Puru, who has joined us from Europe. So that's why it is virtual. We would love to have such interactions in person as well, and we do organize those in different parts of India. So, what is ProMFG Media? Let me just brief you. So, ProMFG Media is a publishing media and consulting organization focused on MFG, which is our manufacturing or manufacturing for growth. And we curate such knowledge sharing sessions across India, as I said, in person or virtual, on variety of topics in variety of sub-segments of the manufacturing, automotive auto component being the largest. And today's focus is the automotive manufacturing ecosystem, the automotive value chain. And my name is Manish Kulkarni. I'm one of the co-founders of the organization. On this call, we also have some of my colleagues. So I will just say their names. Bianca is from the editorial team, but they will not be participating in the discussion. And Ninad is from our project execution team. So these are the people who are on the call. And with this, what I would request all of you to briefly introduce yourself. We'll start with Bhushan. And in 30 seconds, just introduce yourself, your current role and experience. And we'll go round the table and we'll end the introductions with Puru, and Aditya will be the last one to introduce, and then he will set the context. Bhushan.
Sure. Good evening, Maniji and the entire team. I'm Bhushan Badguzar, having total 21 years of experience in the automotive sector in the multiple domain. Presently, I'm working with the Adweek as a head of the plant and leading the two plants in Pune itself. Thank you.
Thank you so much. Nilesh.
Yeah, hi, myself Nilesh Hazare, and I am into manufacturing industry since last 19 years and have worked in various domains of the operations and currently leading manufacturing engineering for Carraro India, where taking care of process engineering, industrial engineering, new product introduction, change management, as well as training portion for the operatives.
Yeah.
So,
And yeah, very nice. Very nice to have you. For those of
yeah.
you who joined late, Nilesh is currently on a road trip to Kerala. So that's why he joined us from the vehicle. And you can stop on the way if you're going via Goa. You can stop. I'm based out of Goa.
Yeah,
Okay.
surely, sir.
Nirmal?
Yeah, good evening, Manish and team. My name is Nirmal Kumar Naik, and I have been in industry since 27 years, and I worked in many domains in AME, then for new project, and currently I am working on the operation. And from the group side, I am the council member of the Industry 4.0, and any investment coming into the group that is the responsible. But currently, I am in purely working on the operation, and it is in Eaton, Ranjangaon plant.
Eaton Razat, the vehicle powertrain manufacturing.
Yes,
Yes.
yes.
Anand?
Yeah. Myself, Anand Prashant. Nice to meet you all. I am from Antolin India Private Limited. Currently, I'm heading Operational Excellence Department in India, Thailand, Vietnam, and Indonesia. So I am responsible for all the operational excellence activity and continuous improvement activity. And I have been in this industry for 13 years. And also, I was certified Toyota Production System trainer from Toyota Kirloskar Bengaluru. I was there for 1 year training program, and also I'm a certified Six Sigma black belt holder. Thank you.
Excellent. Excellent to have you, Anand.
Thank you.
Puru?
Hi everyone, I'm Puru Rastogi. I'm the one of the co-founders of Mowito, and I generally handle the technical side of Mowito and the US sales and marketing. And I'm based out of Detroit.
Currently, you are in Europe time zone, right? Yeah.
Yes, currently I'm in Dublin. My family
Dublin.
lives here, but our second office is in Detroit, so I will be moving to Detroit on Monday, this Monday
Ah,
itself.
Okay, wonderful, wonderful. Great to have you. Yeah, Aditya is also from Mowito. He is one of the co-founders. Aditya, please introduce yourself, and also, Aditya, I would request you to set the context of this discussion.
Yeah, so good evening, everybody, and welcome to the forum. I'm one of the co-founders of Mowito, like Puru already mentioned, and we've been building Mowito for the past 5 years now. My background is varied. I have worked in software services, software products, and multiple startups. And lastly, I was actually building consumer hardware. So I think I have a glimpse of different sectors, and I've drawn from various experiences to build Mowito. So at Mowito, yes, I am handling most of the customer outreach in India and the operations, India specific operations that we're doing. Okay, and why have we gathered here today? Essentially, what we would like to know is your personal journey in your companies with regards to automation. What are the challenges you have faced, and what has kept you deploying robots at scale? Right. So this is the learning we would like to take away from today's session. And lastly, we would conclude the session with a short presentation from Mowito itself, short presentation and videos. But more important is for me to hear your experience on what automation has meant for you and why it has been challenging to deploy at scale.
Yeah, absolutely. Yes. So, automotive industry is going through a huge transformation, both in terms of design and manufacturing, and especially if you look at the disruptions happening or the challenges are related to number of variants and uh, low volume, low volume, high mix kind of products. So those kind of things which are also because of the regulation, because of the consumer demand, because of the multi-fuel systems which are getting introduced. So it is ever evolving and it is always challenging. So agility and flexibility is the need of the hour. And I'll start with Bhushan, and also Anand can take this question after Bhushan. Is when investing in flexible automation, which KPIs matter the most and why? Bhushan?
Sure. So, first of all, thank you, Manishji, and the team for this wonderful opportunity. In fact, it's privilege and honor to be the part of this manufacturing leadership roundtable conference, which is planned today. So, when I see, let's say, currently my role is also at a plant head level and working closely with the CXOs. The one common thing which I've observed in the industry is that we all are here to generate the profit and create a sustainable growth. But if we see the automotive manufacturing is going through the automation to the cognitive system, where we were talking about nowadays because of the high product mix and low volume. That is every organization going through the similar kind of the challenge, and that is especially because of the increased market volatility. We know that there are different model variants which is coming in. The EV, we know that the EV variants are increasing complexity. In fact, the regional customization is also playing a very vital role. At the same time, the shortest product life cycle and the labor's cost impact a lot. So considering the fact, I believe there are the multiple KPIs which we also traditionally monitor. Let's say the OE was one of the predominant key KPI, which is tracked in the manufacturing sector, which talks about the availability, performance, and quality as well. Change over time. Then we also focus on how we can reduce the new product development time. But if we see the current disruption, the one of the important thing which will be the differentiating factor for all the industries is that time and flexibility. So how quickly we respond to the customer expectations, understand that, and then quickly, change your process, product, and system. In fact, I would like to share the saying from the Helen Keller, which always she said that the worst thing than being blind is to have the sight but no vision. In fact, we know that the market is going through very different, turbulence in the VUCA world, and if we cannot identify these challenges beforehand, like we talk about these key KPIs, we will not be in the market. So in my view, we need to be very much adaptive. Like Maniji also said at the start itself. So speed is, I would say, freeze and flexibility will define the future for any industry, be it automotive or non-automotive. So, if I want to just summarize the discussion, the cost of rigidity now is much, much more higher than the cost of flexibility, because you cannot have the quick and flexible adoption. You will not be in the part of the game. So that's what I would say to to everyone. We have to embrace this change very, very quick, because the factories that will win in the next decade are not most automated, but they are the most adaptable and intelligent. Thank you. That's my view.
Very well said. The factories of the future will be most adaptive rather than most productive. Yeah, absolutely. Very well said. Anand, your quick comment on this?
Yeah, I completely agree with Mr. Bhushan. The most important KPI which we need to focus when we are doing this automation kind of thing is that OEE. So OEE matters most in any manufacturing industries. So it covers most of the things like availability, machine availability, and performance rate, and also it checks the first time through. So that is the most important KPI which we need to focus. Apart from that, I would like to add two more KPIs which we need to focus more is one is lead time of all the lead time reduction, so which is value stream mapping. Since I'm from background of operations, manufacturing, and operation continuous improvement activity, I would like to have that value stream mapping. Every uh, plant has to do the value stream mapping to improve and reduce the lead time of the order. So we should be more flexible, and we need to react quickly to the demand to by reducing the lead time. So that is the one thing which I wanted to stress. Apart from that, there are many things like labor productivity, so that also we need to focus. And most important thing is that while during the adaptation, we should not have impact on the cycle time of the process. So if the cycle time is more, that will have the huge impact on our most technology transformation will be null if the cycle time is more, and we will not get more productivity in that. So cycle time is also one of the KPI which we need to focus during this changeover activities.
Okay. Nirmal, we heard both Anand and Bhushan. What's your quick response on the KPIs side of it?
Yes, what Anand and Bhushan explained, yeah, that we are agreeing on that. Only thing is that main hurdle is coming in that, okay, Anand he is talking about the OE, and then the Bhushan is talking more about the adaptability, right? Then coming from the OE, what we have experienced, okay, based on the industry 4.0 and all implementation, everyone is jumping into okay, we'll implement the industry 4.0. But prior to that, we'll have to see what is our equipment and machine condition, right? And definitely we'll come to know all these things when we'll be working on the VSM. Thing is that people directly jump onto the, okay, if we'll have the software and if we have the IoT and everything to the machine, then we'll get our expected way. But in reality, when we went back and see, this is the not right time to implement the OE. So prior to that, what we'll do, we'll be working on the asset monitoring utilization, how my asset is capable to implement the OE or SPC or whatever the industry 4.0 tools. Then if my all 5M, if we'll be talking on the man, machine, metal, everything is in line. If those are streamlined, then when we'll go to the OE, then we'll get the correct result. And addition to that, not only to the equipment, machine and all, then in same time, we'll have to involve the team, those who will be working on the all workflow, and same time we'll be make them participant, and same time we'll increase their competency. If we'll do all these things in all front, then when we'll expecting the result, then we'll get the right way or whatever the KPI into the systems. So those kind of will be help. So now biggest hurdle, okay, when we are talking to implement to the anything, we reach out to the project manager or the production manager, but we are forget what about my supervisor, what about my the team members. Then after implementing, when we are involving them, then we are facing the issues. Then it will be better if day one we'll involve them and make them responsible, accountable all these implementation. Then in future also there will be no hurdle, and we'll get right competent people, and it will be not depend on the subject matter expert. Everyone will be knowledgeable, and it will be not dependable to anyone.
Yeah,
And
you touched
definitely
upon.
yeah.
Yeah, go ahead, go ahead.
So, and second thing is that okay, now for the automation and all, biggest hurdle if we are comparing, okay, in India, second thing we will have to see on the ROI, what is my return of investment. So calculation is happening, okay, in direct management mind is coming in, okay, what quality improvement will do, and what manpower cost will save. If we'll see only these two parameters, then it will help you to get the our ROI. So
ROI, yeah,
those kind of hurdles
absolutely.
are coming, so we'll be working on all these from all front.
Yes, yes. You also said about asset management and ROI. Nilesh, a quick comment, and then we'll go into the topic of what Nirmal spoke about is the skill level, upskilling and de-skilling. Yeah.
Yeah, I would probably will not specify anything about the KPI because that depends upon company to company. But few of the point which probably I think needs to be rethink from fundamental point of view. Like in any manufacturing industry, or for that matter, any industry, the work starts with the design, then the feasibility study, then the vendor or the in-house manufacturing, then assembly, then final inspection and handing over that product to the customer. After the design release, there are many checks or the quality gates where you validate the processes or conformity of the product. But most of the time, this designing phase itself gets passed out from this. So something like I would say the manufacturing feasibility or validation of the drawing, if can be done during the process of designing itself, or if we could simultaneously start the feasibility of the manufacturing with design phase itself, it will help to reduce the overall time to market to the great extent. So that is what I feel would be a fundamental difference that manufacturing industry should think of,
Yeah,
which
yeah.
will help us to react to the market in at least in this business of high mix, low volume.
I mix low volume. Absolutely. Very, very well said.
Yeah.
Aditya, we heard from the industry practitioners their views on what KPIs to measure for implementation of these technologies. What has been your experience and what's your view on this?
Yeah, so again, I think a lot of it would be common to what people have said here already. We work with Denso, we work with Indomim, we work with VVDN. One common thing we do here is how rigid things have been in today's automation world, right? So far at least, like for everything, they have to depend on a system integrator who has to come and reprogram things. If there's a slight change in the design of the part, or if there's a new variant that they're adding, they have to design new jigs and fixtures, and there's a long process to the whole thing. So things have been slow, and it's been expensive to scale automation. That's the primary feedback we have received from the industry. And obviously, what's missing here looks like is not the hardware piece, right? So the robotic arms have been there for decades now. I guess what manufacturers are hinting at is, look, we need robotic arms to be able to adapt more easily to any change that comes about in our line. How do we enable that change is the whole it's a different point altogether what we use for that. But I guess they want smarter systems, bottom line, which are faster to deploy and easier to maintain, and where they want to see more power put back in their hands, right? So far what is happening is they're dependent on everything, and that scares them actually. So they want to be like, okay, if something new is added, can the operator take over and do it himself? So this is what we hear more often. But yeah, I would love the gentleman here to add their thoughts if there is anything.
Absolutely. Yeah, yeah. In fact, that gives me a cue for my next question, and we'll move to the topic of since it is related to the mindset, culture. I will start with Bhushan, and I would request after him, Nilesh and Nirmal to take this question, is related to what shift in skills and culture are needed to make human AI collaboration part of daily operations. So the question is about the cultural shifts and the skilling part of it. Bhushan, you're on mute, I guess.
Sorry. Yeah. Am I
Yeah.
audible?
Yes,
Okay.
yes.
So if you see the industrial revolution, that is the industry, the 1.0 till the industry 5.0. So the major shift which we have seen, that's the industrial revolution 3, we were talking about the automation, industrial revolution 4, we were talking about the digitization. And now this transition from industry 4.0 to industry 5.0 is talking about a more human-centric collaboration. Now the transformation, they are hard and the digital ones are much, much more harder. If I see I would say the one of the topmost consulting survey which was published them in the recent times. In that they specifically talk about that the 84% of the failure rate in the digital transformation, and that is the study they have done for the global organization. So this means that only the 16% companies they are executing it the right way. The basic challenges what across the globe is that the resistance to change, what they said is that, which contributes almost 30%. The lack of clarity in the strategy itself from the at a senior management level, which contributes almost 25%. The leadership support in this challenging time is contributing the 20%. One of the key aspects what they observe is that the insufficient skill and training, because we have the resources, but whether the resources are ready to adopt this change because of the new trends in the market. Like we are talking about the digital twin, now we are talking about the 3D printing, we are talking of the AR and VR application, but whether we have the right resources who can adopt this change very quickly. So I think because of these challenges, and one of the important thing is that in fact the 20% contribution is also for the poor change management. In fact, this is what is the survey which is published. And if I even see from the being we are from the automotive sector, so the IATF, if you see globally, the top one non-conformance in the IATF audit is because of the poor change management, right? So if you see on the broad perspective, what I believe is that the one of the challenge what industry is facing, if you want to overcome, the most important thing that in the is that how we can bring that AI literacy across the organization, across the various level in the organization. Like we're talking about, the people should understand how the digital twin will help to develop and fast track my new product development cycle. How the robotics and AI vision or cameras can help me, on the shop floor to reduce my defects significantly. How the 3D printing is helping us, to prepare the prototype much faster than ever. So I think it is very, very important to have the smart and connected factory with the IoT application. So I think that will help us to a greater extent, but we have to focus more on building the AI literacy. Apart from that, once we have everything, we have to have the data-driven decision making. When I'm talking about the data-driven decision making, we should have the dashboards which will reduces our time of the analysis, stratification of the data, and which will help us to make our decision faster based on the real time and real data. Third important thing is that we have to encourage our teams the cross-functional approach, how they can come up with the agility and innovation in the entire value chain. Like one of our team members also talked about at the start itself, that we need to understand the requirement, how we can absorb that requirement and quickly focus on the development time, which will help us, to define the product in a robust way, design the process which will enhance and help us to produce the required specifications. We have to define the system which will enhance the current performances. So this is very, very important to have the cross-functional approach. If I just wanted to summarize this discussion, the technology transformation is spelled without the mindset transformation. So we have to have the cultural change and the mindset that we have to bring the transformation in organization. Then only this technology which is available in the market will help us, to make ourselves as a differentiating in the competitive world. So thank you. That's my view.
Thank you, Bhushan. So, Bhushan, you mentioned about this delegation visit. So, I would, uh, I would ask you one more follow-up, quick answer I need, and then since you have to leave in next few minutes, you can answer this quickly. You mentioned about this AI-driven systems.
Mm-hmm.
How can AI-driven perception and vision-guided robotics make shop floor operations more intelligent and responsive in real time? This is my question to you. A quick answer in next 1 or 2 minutes.
Okay, absolutely. So if I see that, if I have on, see, there are three important aspects when I'm talking about the benefits of having the technological, the technology within the factory is that I can significantly improve my quality performance. If on my end of the line, if I have the vision cameras, that will ensure that a defect will not pass on to the customer. If I have the Pocoyo case, inbuilt Pocoyo case, which will ensure itself my defect will not create on the shop on my particular station itself. Okay, even if it is produced, for example, it should not pass on to the next operation. So at every stage, we should have the controls which are inbuilt into the system. That is called the robustness in the process, which will significantly reduce my defects and improve my quality performance. Second important thing is that it will reduce my cycle time or reduce the overall time which is required for the product performance. If I have the robotic operations, I will save a lot of human intervention. If you see in the today's world, there is a lot of dependency on the contractual employees, and then they are frequently changing in the industry. So we have to train them. We have to invest too much amount of the time and money. If they leave the organization, it's a loss to the organization. So that is the second important thing. And third and most important thing, whatever the technology which I talk about in the couple of minutes, digital twin, AR, VR, which is helping us to training to the operators, identifying the challenges, and that is helping us to overall improve the throughput of my process. So in a nutshell, I will reduce my complaints into the market, and it will improve my overall bottom line of the business, the overall performance of my business by the
Yeah.
application of all these technological enhancements.
Okay. Thank you so much, Bhushan. Thanks for this comprehensive answer. And in case you have to leave now, I'm still okay. So
Thank you
thank
so
you
much.
again for your participation. I
Thank
know
you,
that
team.
this was still you could take out time to be with us for this half an hour. Thank you so much. We'll be in touch.
Thank you,
Definitely, and
Bhushan.
it was
Thank you.
it was wonderful experience and privilege to connect with each of you. I would have
Yeah.
loved to extend, but because of some priorities, I have to please allow me for some time.
Yeah.
Thank you
It's
so much.
absolutely
Thanks a
fine.
lot
Yeah.
for coming over. Thank you very much.
Thank
Thank
you
you so
for
much.
coming
Thanks.
over. Yeah, absolutely.
Thank
So
you.
we'll go with Ms. Nilesh Hazare on the question of driving this cultural change and upskilling, reskilling, or deskilling. These are the terms what we hear uh, for this human and AI collaboration. Your views and perspectives, Nilesh?
Yes, so I agree with whatever Bhushan has said earlier, but would like to add few point with whatever experience that we faced during implementation or during this transition into our company. So basically, practically, management thinks of these strategies, and we try to impose them on the shop floor with the supervisor and the last person, the operator who actually uses it. So instead of imposing these changes to them, if we make them part of the solution, or if we make them as an enabler of this change, it would be really helpful to implement these AI technologies or the IoT based solution into a factory very smoothly. Because we have introduced the barcode scanning or traceability of the operation in 2012. So more or less 13 years back in my company. But that time, operator were very reluctant to use this barcode because the sole purpose they found is that capturing their time. That if they scan this barcode, then it will be the timing of the operation will automatically logged into the system, and it will be a tool for the management that who is doing what for how much time. So when they were free, when they were working, So because of this thought, they were quite reluctant to use this barcode as a tool. But then, before facing such kind of resistances, one should make them aware before going for such systems, so that you make them part of the solution and not a part of the problem. So this is what is my takeaway. And in the current scenario, supervisors of assembly lines or the machine shops, so where these kind of systems are being implemented, they should be given some adequate knowledge or the training for these systems. So basic know-how for the this IoT has to be upscaled into this industry. So it would be better that someone comes up with some basic courses which talks about how this integration happens, how this data communication happens. If some sort of log is generated, then who probably is the responsible person, whether it is maintenance or it is the assembly supervisor who has to retrofit some of the activity, or it is really IT related issue where the IT person has to get involved and try to fix up the things, or at the end it is the supplier who can only resolve this kind of issue. So basic troubleshooting and basic knowledge should be imparted at this supervisory level. So
Okay.
for this, I would say that there is a strong need of some basic generic training course, which should be applicable more or less in all kind of industry. That would help to give the confidence and basic knowledge at this level.
Okay, thank you, Nilesh. Nirmal, your perspective on this topic, and then we will quickly take Aditya's response to this. First, you go, Nirmal.
Yes, my perspective to this human and AI, actually, if we'll, as a leader, then we'll have to go through the right workforce strategy. We'll have to work on the right management workforce strategy. And it is not only to the limited to the plant, it will be limited, will be same time looking for the right supplier and who will be manufacturing all these. The second thing, we'll have to move, right? From the skill transformation to my culture transformation. If we will be talking on the skill development, or not only will be within plant, in same time this same skill and same requirement will spell out with our supplier. Then when supplier and plant they will be working on the requirement and the skill, then will be well executed. And coming to the culture in the sense within the plant and the impact with the supplier, how the supplier and plant both the team work together in well trust and well transparently, that the leadership will be looking on that. Then second, we'll make them their mindset. Okay, initially if we'll see if people are working since a long time, and today if we'll ask them, okay, these are the changes coming in their life, never they have used computer or anything. Today we'll ask, okay, you will use the computer or HMI or anything on the high technology system. Then due to the fear or due to the unwillingness, they will be not comes out. So we'll have to moving them from fear to participant. We'll make them participant. Then when they will be involved since day one, and they will be working with us, okay, what we are doing and what will be going to be done in future, then it will be easy for them. And they will be also the part of, if some problem we are facing in between and how we are resolving, that they will be also part of that. Then in same time, we'll develop the culture with the team in lifelong. It will be not, okay, if we'll be talking on safety, quality or CI, it is not only the event basis activities. It will be our day-to-day activities. In every activities, we'll be thinking on the safety, quality, and productivity. When we'll be in Gemba or something, or when we'll be in project review meeting. So what kind of question we'll be asking? Same question maybe will not repeat in every each and meeting. We'll be changing our, okay, on which part will be act today, and we'll teach them. So in they will have to building every day how will learn. That kind of culture will have to develop. And the second thing is that suppose meeting is happening, he is the part of the team, then we'll have to involve them. We'll okay. Sometimes what it is happening, okay, he's not in A shift or he's not in B shift. Okay, without them, we'll do the meeting. It will be not like that. Based on their availability, we'll make our time available and we'll work them. Then they will be feel better. And in fact, when we'll coming to the change management, okay, then it will be not a hurdle. There will be no resistance. Easily they will accept and they will get into implemented. If there will be in between any AC issues, then they will not raise the concerns. They will think that this concern is not to any management or any department or compartment. It will be our problem. Then they will involve and they will resolve all these issues. So here, so three things will have to work. One, the artificial intelligence, then human intelligence. In same time, also will be working on the emotional intelligence. That will be the also most. So all three intelligence will have to bring together and work together. Then will be a success on the team and
Yeah.
on our result. That is
You concluded on a very interesting note, three types of intelligence, AI, EI, and HI. Very interesting. Aditya, this technology implementation should be actually, for example, we are all digital these days, so we have adopted to new technologies in our personal life so easily. I mean, similarly, for such complex manufacturing, these upscaling and driving change management and driving cultural aspects in the organization. What has been your observation having worked with different industries?
Yeah. So I think one thing is very clear, Manish. I mean, the success of automation finally comes down to the operator on the line, right? So wherever, if they have not understood even how the UX is, if there's bad UX, they tend to bypass that and just do things manually if that is possible, right? So I think finally there is no walking away from the fact that people have to be upskilled. It is, I wouldn't sometimes call it upskill also. There's a resistance to any change, right? There is a force of habit that's working against it. They've been doing something in a particular given way for maybe 5 years, 10 years, 15 years, and suddenly you say this is not how we're going to do it, but this is the new way. There is obviously going to be a lot of change. I think it helps to make that, if to the extent possible, make it gradual. Right. So don't enforce a very large change on day zero. Uh, Start with smaller steps and make them comfortable with the user interface. One option could be, for example, you want to give the user interface in multiple languages, maybe, right? So not everybody may be very comfortable seeing a user interface only in English. So do you want to give an option for a different regional language to be a part of the UX? So some things like that could help to bring more to reduce the friction involved in adopting technology, because finally the operator has to be the one using it, right? No matter what the management thinks, no matter what the leadership thinks, he's the one who will have to face it day in and day out. So I do believe making it easy for him is absolutely crucial.
Absolutely. Anand, I'll take this question to you first, this question about AI and vision use cases. And then I would also request both Nilesh and Nirmal to add their views on it. But first, Anand, could you please share which AI and vision use cases seem most promising to you on the shop floor?
Yeah, thank you. The first thing that I would like to tell you about eye precision quality inspection. So for us, we have implemented one concept for detecting the surface defect detection mechanism we have implemented using the camera. So while identifying microscopic cracks under zero point 0.1 mm scratches or paint inconsistencies, so that has helped us really useful AI implementation that we did, that has given real benefits, because the first thing we do in manufacturing industry is to protect customer line at any cost. So that is the first thing we have. Customer is king. So we wanted to protect the line. So for that, we wanted to use this automation for detecting these defects which can pass through human eyes. So that is what we have implemented, and that was really promising, which is giving us 95 to 95, 99% efficiency and accuracy for detection of defects. And second thing is one more thing we have implemented, which is also most promising, is that vision guided robotics and safety. So which we have implemented, enabling robotic arms to identify and pick parts in unstructured environments. And also it is adjusting their trajectory in real time for tasks like precision of welding. So that is one thing we have implemented. And one more regarding this work safety and ergonomics, AI cameras we have implemented to monitor the shop floor for PPE compliance. So AI detects the persons who is walking on the shop floor. It is a existing CCTV camera we have implemented that we have adapted into this PPE. If if some people are missing their PPE in the shop floor, it detects there which PPE personal protective equipment they are missing. It is giving alarm to the people who like safety officer. We have linked it, so it is sending some messages to the safety officer. This PPE is not used in the shop floor, so we can immediately correct to avoid near misses, and also future accidents can be avoided. So that is one thing we have implemented. And also it is not only detecting whether the operators is implemented is using the right PPE. It is not only using the PPE, and also it verifies whether the operator uses the right PPE in right way. So that is the one important things we have implemented for safety aspect of our people working in the companies, because those two things are very important to us. One is protection of customer lines, so no defect outflow to them. And second thing, we should take care of our people. Safety is our priority. So we have adapted AI's vision cameras in this technology, and we have adapted in our lines.
Okay, so you spoke about product quality and safety.
Safety, yes.
Safety, two use cases. Very interesting. Nilesh,
Which we have
would
implemented, and it has given very good
it has given.
results to us. Yeah.
Okay, interesting. Nilesh?
Yes, we do have vision systems available in our factories, mainly for the detection of the part presence, then correct orientation of the part. Recently, we have implemented vision system to detect the correct part for our robotic washing machine. Earlier, it was a program based that operator have to select the program based on the part, but now this is automated with a vision based system, right? Vision camera detect the part and automatically the program gets selected. So earlier it used to be a vision system. Now it is AI-based vision cameras where the intelligence is added. But still, I would say the difficulty with the current systems also is they need a lot of fixturing or the correct posture or the correct positioning. However, with the coming time and with more understanding of this subject, we may see some flexibility into this system where they could automatically take the reference and guide through the complete program and intention with which they are put in place rather than being in the some specific position. So I hope
Okay.
this is the things to come in the future, or
Okay.
we expect at least them to have.
Okay. That's your you're working on it, or that's your wish list basically.
Yeah, that is our wish list because right now their positioning and settings are very much important for the better results or the
Hmm.
perfect results. So if something missed out in that, then there is a variation in the result. So I
Okay.
think that constant should not be there in the future.
One
So
thing
system.
I wanted to add,
Yes,
sorry. Yeah.
please.
When I went to LML college for one college event, quality circle competition, so there I have seen one third year engineering graduate. They were doing this AI vision camera. So that CCTV camera is there. So it detects unabnormal motions of any people. They have projected some rubber bullet gun they have placed. If something abnormal activities of a person through the body language, so they have identified that body language inappropriate to that particular location, and that bullet it is fired towards them. So that is the basic idea that we got. And initially we have worked on one more concept, like we have visual inspection at the final inspection area. Okay, the same concept we wanted to do it here. So we have 10 the part has to be inspected 360-degree. So we have checked, we have set 10 points which operator has to check, and CCTV camera which we have already using that. it focuses on the final inspect operator, and it tells us if we missed any one, if the part is not 360-degree inspected, it gives us alarm with the buzzer sound. So that is a simple automation we did, which is very effective. That even if we go for full automation, that will cost us more. But with the existing technology, if we detect that we believe in operator, so if we misses some inspection points, that will highlight and inform immediately to the supervisor, so that defect outflow will not go to the customer. So that I
Hmm.
wanted to add it up.
Oh, yeah, it's a good point. Yes, absolutely. Nirmal, and then what we will do as a sequence is, Aditya, what I feel after Nirmal's inputs on this, it would be a good time to actually go through your small presentation, if you don't mind. Is that a good time?
Yes, absolutely, Manish.
Yeah, yeah. So, Nirmal, your quick views on use cases as well as your wish list for vision-based AI systems.
Yes, Manish, our plant is a manufacturing plant. Mainly, we are manufacturing the transmission and for the transmissions and gear and software manufacturing. Then in a transmission, not less than 300 part is get into assembly, right? Then if we see our man force, 30% is the permanent and 70% is the a training and flex people are working. And training in the sense, if we look the attrition every day, 10-15 people get in and get out. So those challenges are there. So in our assembly line, we have three assembly line. One is 6-speed transmission, then second one is the 9-speed, and the third one is the XY shifter. Then here, what we did, we have implemented the pick to light. Pick to light in the sense that based on the bomb and model, it will give the sequential trigger, okay, on which part will get into the transmission in sequential. If operator, they will do some mistake in choosing the sequential, then the supervisor will get the alarm. Then that we were looking. Then second thing is that coming to the my standard time, it is mainly depend on the my operator performance. If operators they are not follow the standard time, then it will be impacting my the cycle time. So in that cases, for the viewing the operator activities, like okay, his moment, if he will not follow the moment and not do the assembly, then cycle time will be differ. Then in that case, AI camera is there, then camera will look. If there will be some issues, then it will be not allowed to the second assembly. Then his friend, you will indicate you have done some mistake in your sequential, then it is not allowing me to do the further activities. That is the one. And coming to the quality, yes, part presence, we have many vision camera. Then one more thing, coming to the machining line. Okay, my the 206 machines are there, and all machines are get connected to my the metallurgy lab. And if any quality issue will be there, my metallurgy lab person, he has the authority. We have given the authorities. If he looks some abnormalities in quality or process, he can stop the machine from the metallurgy lab. Then my operator or supervisor, they will come, okay, what it is happen. Then get the detail from the metallurgy lab. Then again, they will reset the machine and then they will start. So that way we are integrated all the systems together to capture the quality and productivity. So that systems it is present. And coming to the safety, yes, what Anand is mentioned, it is a good part, but that is our next project. Will be working on the safety.
Also on the safety. Okay, thank you, Nirmal. Aditya, we heard the implementation of some of these and also heard some of the wish list items on the top of their mind. It would be a good idea if you can take this further and
Yes.
also present about Movitos and your own use cases which are already in the industry. So who will be presenting? Maybe if you have sharing
I'll
rights.
be presenting.
Okay.
I
Do you
just
have
sent a share
the
request. So
sharing rights?
yeah, no, I do.
Okay, great. So we'll go through this presentation. It's very interesting to know also from Mowito
Yeah.
on some of the use cases. Yes, we can see
So
the presentation.
yeah, I hope everybody's able to see it. So Nilesh, I think we heard you, right? So you
Yes.
relate to a lot of what we are going to say now. We are at the intersection of AI and robotics. We are building software solutions to improve the intelligence of robotic arms, robots that can learn from human demonstrations and then control the arm autonomously uh, using a mix of vision and tactile sensing. And our robots can do high precision assembly and inspection tasks on parts that they've not encountered before and on parts that are even flexible in nature. So that's the capability we are giving standard robotic arms. So this is the core team. Puru and myself, we already met. Safar is our director of engineering. The good part is we come from diverse backgrounds, but we also have a lot of robotic experience in the team, right? Starting from the top. So we are close to now around 30 people, including trainees, and we have a substantial team in Bangalore, and we also have a satellite office in Delhi. So again, coming back to where AI is headed, physical AI is now considered the top of the heap, right? So we went through multiple phases of AI, starting with perception, generative, agentic, all of that. But now clearly it's the era of physical AI where we are trying to see how AI can improve the day-to-day interaction with various objects, right? And it's I mean, industrial AI is just a segment of it. Today they're looking at robotic arms doing everything, even at a house. So that's where we're headed. That's the whole direction in which AI is headed. And if you look at how automation has been in the industry so far, traditional automation, typically we'll have a system integrator who starts with a standard set of components like a robotic arm, camera, and gripper, and then adds vision AI software, usually from a Cognix or a Keynes. They are the big daddies of the vision world. But lastly, he writes custom software for a particular task, right? And this is what the integrator will do and deploy the whole system. Now, the challenge is whenever there is a change in the part design or whenever there's a change in the environment, this custom software has to be redone. It has to be rewritten. And then you call the integrator back. He has to do his modification. Sometimes it involves redoing some jigs and fixtures. All of that takes time and effort and money, of course. And this happens every time you introduce anything new in the line or anything changes in the line. What are we trying to do? We are trying to walk away from that paradigm completely, remove all the Vision AI software and custom task specific software now, and replace it with one AI model which controls the robotic arm. And this AI model is capable of handling most of the standard tasks, including inspection, assembly, and soon wire harnessing as well in the assembly line. Right? So these are the tasks we focus on. And we want the AI model to be capable of handling these tasks without the need for jigs, fixtures, and other paraphernalia around it. Let me just show you a quick video. So if you can see the video playing on the screen, what you're seeing on the left is operator demonstrating the task to the robot. Now, as he demonstrates the task, we are collecting all the values from the vision, joint sensors, torque sensors, all of it. And we are fine-tuning our model. The AI model is already there. It's being fine-tuned using these demonstrations. And once the demonstrations are done, you can see that even if the part is being moved, the robot is able to accomplish the task successfully, right? So it's now completely autonomous in nature. Of course, there's a camera on the arm, which you may not be able to see. We are using a camera. So all of the data from the camera, from the torque sensors, from everything is being used to fine-tune the model and to help the robot understand what does it mean to complete the task successfully. After which it becomes totally autonomous. Now, how does it play out on the line? Just to give you a live example. On the left, you see a traditional inspection line, right, for a car chassis. So the chassis comes, it has to be in that particular location. The robots are hardwired, they're hard programmed to go to particular locations and take images. If there is any change in the way that car, in the position of the car, the robots wouldn't be aware of that. They just take the images that they always take, and the images may not be good at all. They may not be useful at all. But the robots still don't know where the car chassis is. They are all working in silos. They're all independent of each other. But what you see on the right side is what we have implemented at Denso, which is one of the largest manufacturers of alternators. Now they have a line to inspect alternators, and they have 8 or 9 different variants of this alternator. It's not just one variant. And they wanted a fixtureless line for this inspection because the moment you add fixtures, you cannot work with different variants on the same line. It becomes a constraint. So to remove the constraint, they wanted a fixtureless line, and on top of it, upstream, this alternator is being placed by a human operator on the line, which means that there can always be a change in position or orientation. They wanted a system that could accommodate all of this, and we have delivered a system with a cobot with 2 cameras on it. Now it automatically tracks the part, aligns to it, and captures images for inspection and inspects it. All of this without stopping the conveyor, right? What they were earlier attempting with 6 or 7 different static cameras, we have replaced with one system which is operating on the fly and delivering the result they needed. No jigs, no fixtures, no stopping the conveyor, improved throughput, all of it in one go. And it's not just inspection. We have graduated from inspection. Of course, inspection is what we started with. We now do wire harnessing, assembly, even machine tending. What I'll do now is I'll switch over to some videos of these particular use cases, and feel free to stop me if you have any questions in between anytime. Let me just share a few videos.
Yeah. And if any of the panelists has any query, you can please feel
Yes,
free
I
to.
have one query. I have
Yes.
one query.
Yeah.
Okay, in AI vision camera, up to what accuracy we can capture?
So it depends on the use case, and it depends on the camera itself. So what we do is we don't use the Cognex or Keen's cameras. We decide on the camera, either it's a Basler or a FLIR or a IDS camera that we use. Now, which particular lens we use and which particular camera we use and the resolution of the camera is decided based on what is the size of the defect you want to capture, right? We have
So
gone up to
can
10.
be it can be feasible in micron, or it will be 0.1 mm or 0.2. Okay, till I have heard of, it can be captured up to 100 micron. If I'll be talking on the 3 micron, 4 micron, then that can be feasible.
We have not gone up to 4 micron. The lowest we have gone up to is 10 micron. This is on ceramic parts for a company called Indomim. It goes into an oxygen sensor for Bosch. Those kind of use cases can be done with vision cameras, no doubt about it. 10 micron is possible. The challenge usually comes that when you have a 10 micron defect, my field of view is not very large. It's a very small field of view, which means to cover a large part, it will take a long time because I cannot cover it in one image then. I have to take a sequence of images. So if you have a 100 part, I might be capturing like over 100 images or 50 images to cover the whole part at that defect size. That will be the main challenge. So your cycle time may not there may not be enough time to do that kind of small window capture for the whole part. So that was the ceramic part that we with is very small, right? So that's feasible. But if it's a very large part and you want to capture like a 10 micron defect, it requires a lot of images.
Thank you, Aditya.
No problem. Inspection of a whole car chassis. This is a POC that we're doing in MSI, Maruti Suzuki.
If you're displaying something,
yeah,
we
I'll
can't
just
see.
just share my screen. I'm not sharing my screen yet.
Yeah.
Is it? Can you see the screen now?
It's coming up, but yeah, now it is visible.
Yeah. So this is for the cobot-based feature inspection for a end-of-line inspection for a car chassis at MSI, where they wanted to tally the features with the variant because it's a multi-variant line. So different variants come on the same line. And obviously they cannot stop the line to inspect. Today what's happening is operator holds a tab in his hand. He has to bend inside the chassis, look at the various features, and he has to fill checkboxes on the tab. But that's obviously it's very hard to do this for 8 hours a day when you have to bend and look at, move across the line and all of it. So with this solution, what they're getting a solution where the cobot is automatically tracking every chassis that comes on the line, aligns to capture different images of different from different focal points, and then analyze the images to at runtime to say, okay, this feature is a part of this variant or it's not there as a part of this variant, which is wrong, and then flag that. Right? So that's something we have implemented. Again, this is without stopping the line. This is a use case for machine tending, which we have again deployed at Denso. This is a AMR based machine learning. This is handling 4 machines in one line, right? And it has to pick the part, place it into the machine, take the part from one machine, place it into another. Of course, the cycle time was sufficient enough to do this task. But the real challenge here was the AMR vendor here is Peppermint, which is again Pune based. But the real challenge here was we had to accommodate for the inaccuracies of the AMR because AMR will stop with the 10 or 15 inaccuracy, but I have to place it with a 200 micron. I had to place the part with a 200 micron accuracy in the check, right? So to enable that, we're using a mix of vision and force feedback. Let me just go a little back. And if you see, I'll slow down the video a bit so that you can get an idea of what I'm talking about. So at this point, the camera actually loses focus of the check. I cannot see anything that's happening. So I am completely going by force feedback to say whether the part is butting against the check or not. Right? So we're using the torque sensors available in the cobot, and it actually wriggles the part just like how a human would do it. So that it butts against the base of the check.
Just to add to what Aditya said, in a summary, basically, in ideal world, if everything was very accurate, vision system was not required. But as the AMR is a physical system, not only it will have inaccuracies in where it stops, 5 to 10 centimeter, even in the yaw angle as well. Further, when the arm extends, there will be a tilt in the orientation, in the position, in the orientation of the AMR. Right? So when you actually operate it in the real world, there are a lot of inaccuracies. And as you might be aware, the chuck, when you fit the object inside the chuck, the clearance is very low in most of the cases. In this case, it was 200 sorry, 200 microns. Right? And in the case of CNC machine, there will be water coming out, or not water, coolant, and everything will be coming out, which can affect the vision of the system. Further, in these close quarters, the vision does not get the full view. So we not only are using vision, we are also depending on the tactile to make sure that the loading and unloading is a success.
So this is a small part assembly system, which we have, I'll demonstrate it right now. So this is for the wire harness dummy seal insertion that we have done. But of course, it's not restricted to dummy seal alone. It can be used for any small part assembly. What you cannot see here is there's a camera which is above this feeder that you're seeing. And that's what is actually guiding the arm, right? So this feeder that you're seeing, the vibratory feeder, right above that, there's a camera. And that's what is guiding the arm to pick from the right slot and place it in the seal. Right? So any bunch of small parts can be used. This system can be used to assemble any of those small parts that are required in high volume. And right now we are working with another company which wants to do assembly of seals with this system. And of course, from the wire harness industry, we already have ready orders for this. And we have delivered a full inspection system to a company called Tweezerman. So Tweezerman is a German company which manufactures tweezers for the beauty industry. They're based out of Pondicherry. And this whole cell was a full end-to-end development that we did for them to inspect the symmetry for the tweezer lips. Because tweezers, the lips of the tweezer have to be symmetric. And we are looking at a 0.05 symmetry scale here for the two lips. So the UI that you see, like this is what I was talking about earlier, right? The user interface plays a huge role in how much the system or how quickly the system is adopted. And the entire UI was built by us. So it does three passes. First, it has to check the height. Then it checks for, it arrives at the right focus and checks the tweezers. The bottom, you are seeing the two black lines. That's actually the two lips of the tweezer. And we are comparing the two lips. And again, the UI that you see, the green ones are good. The different colors mean different things. Like both of them are thick or both the sides are thin or something like that. And then we pick out the bad ones and put it in a separate bin. So this entire system was developed as a turnkey solution for them. And it's now being used in production.
Aditya, I think you based in Pune, right?
We are based out of Bangalore, but yeah, of course, Pune, we are getting a lot of inquiries. So soon, I think we will also start something in Pune.
Okay, when we'll be in Pune, can you visit our plant? Then we
Yeah,
have some
definitely.
challenges.
Yeah, sure. Why not? I'll definitely visit. Yeah, I can pay a visit just for that. Not a problem. Yeah.
Yeah.
So I just wanted to show another video about the assembly itself, what we call as two-part assembly. So you saw the inspection of the alternator earlier. We are extending that whole concept of vision-guided robots to assembly. Now here, what you're seeing is as the alternator moves on the line, we are actually assembling a part on the alternator. No feedback is coming from the conveyor. It's completely doing this at the vision layer. It's tracking the alternator, aligning the pins, and placing the part. I'll just replay the video.
Just want to add one more thing here. The reason we are not taking a feedback from the conveyor is one of the benefits of that is that the integration time reduces. So, for example, if the line is continuously running and you do not want to stop it, you just need to put the robot arm next to the conveyor on a pedestal and it will be ready to work. This is how we did POCs at Maruti as well, because the main assembly line, they will not stop it for us. So we just put the robot arm on a pedestal and placed it next to it, and it was ready to go.
And the other
So it
thing,
is implementation is without any disruption to the operations.
Yes,
Okay.
absolutely.
It can handle a variety of takt time.
uh,
Takt time,
sorry,
actually, so Aditya, the question is, can it handle variety of takt time, cycle time, basically? So, sir, takt time, it's it depends, right? Finally, what is the operation the robot arm is doing? Our vision system does not take a lot of time, but for the robot arm to move from one place to another, some actual time or actual motion
No,
happens, right? Yeah.
probably in the same example, let us say the system is designed for let us say to produce 500 parts in a shift. But my requirement today is not 500 but 200. So the line will run with the lower speed.
yeah.
So in that
Oh,
case,
yes.
will I have to configure it with the new setting, or with the current setting it will adjust itself and adjust the time according to the new tag?
No, it will automatically adjust.
Yes.
It will automatically adjust. The speed that we have done so far is around 90 mm per second of the conveyor. So we are not
Okay.
basically
So
we are not using
anything
conveyor
below
speed.
that, yeah, anything below that it will
Exactly.
adjust.
Yes, automatically. Anything below that automatically adjusts because we're tracking the part itself. We are not taking conveyor
Yeah, yeah.
speed.
Yes,
Yeah,
yeah. Even if you have not considered conveyor speed as an input, but anyway, the speed of the part is defined by the conveyor. End of the
exactly.
day,
Yes, sir.
Exactly.
probably it is not input to your system, but yes, that speed will be governed by the conveyor only.
Correct. So yeah,
Yes, sir.
up to 90
Yep.
mm per second of conveyor speed, we have been able to place the part like this, like what you saw.
Mm. So even if you
Okay.
stop the conveyor or reverse the conveyor, it will automatically adjust to that.
Okay.
Okay.
Anand,
Okay.
any question? or any observation from your side?
No, it is great. Maybe I will contact Aditya to know further.
Yeah.
Yeah.
So this was another demonstration. We had by the way, a stall at Imtex this year in January, and this was another demonstration we had there for tactile inspection. So if you look at any vehicle, of course, we are showing it on a bike's instrument cluster, but it can apply to car or it can apply to any place where, see, some inspection can happen visually, right? But even with cameras or something. But there are some cases where still a human is involved wherever it involves a touch and feel kind of operation. Here it's like a human would be checking every button of a vehicle on the assembly line. How would you automate it? You would use something like this, right? You would have to use a system like this. That's what we are demonstrating here, where we have mapped the signature, the force signature of a button that works normally, and the moment it does not match the force signature for that button, we know that it is faulty, right? So for every button, there's a force signature, like be it a horn or be it the light switch or be it the indicator. There is always a normal force signature. If you see the bottom of the screen on the right side, it is showing you what is like the particular force signature for this button. Now, if the same button is faulty in another vehicle, we know that it does not give the same force signature. That can be seen. And in some cases, the gripper can also be a simple gripper, and we can use the cobots force sensors to achieve the same result. It depends on what all axis we have to measure the force in. We have also now started working on dual arm use cases. I will just show you a quick use case in wire harnessing that we are working on for specific customers. This is two Fanuc cobots which are able to handle a harness. And of course, wire harness, there's barely any automation available today. It's completely manual because current set of robots cannot handle flexible objects, right? In the way they are programmed. This kind of application where you require multiple cameras, multiple force sensors has not been done. And we have demonstrated this at Imtex. It picks up a harness and lays it out the way it is usually done in the harness industry. This is, of course, step one, post which we will obviously do the inspection, taping, cable tying, all of that. But we have been successfully able to figure out how to handle flexible objects like this, and so that we pave the way for the next set of operations on that.
In this specific application, one of the key interests of our customer is the inspection, that we lay down route the wire and do the inspection. But yes, as Aditya mentioned, this is the step one. There will be more automation coming soon on this line, on this process.
Yeah. And one last thing I would want to show is fastening. We are working on dynamic adaptive fastening applications. You can say it's similar to assembly, where the robot automatically tracks a part that's coming on the line and uses a standard tool, like it could be an Atlas Copco or Ingersoll tool, aligns to the fastener and tightens it. Again, without having to stop the conveyor, right? Of course, the torque setting would be whatever you set on the tool itself. Nothing is changing on that. What we are essentially adding here is the ability to align to the part at runtime. And you can see that it even aligns with the change in the yaw. It's not just this horizontal axis. We're also accounting for the change in the rotation of the part. That's about it from our side. I think I've covered
that. Very interesting use cases and videos. I think I had seen it a few weeks back, but this time I think you incorporated more through your recent experiences.
Yeah.
So it was useful to see that. I would take a quick 1 minute feedback from all the speakers, and then Aditya, you can just summarize quickly. Nirmal, Nilesh, and then Anand. Nirmal, you're on mute, I guess.
Yeah.
Yeah.
Yeah, Manish, thanks a lot for arranging this event. Actually, this event is first time to me, and I learned a lot, and I got the opportunity to meet with Anand, Nilesh, Aditya, and Puru. Definitely, it is not just only talking. and knowing each other. Definitely, though globe is very small, right? So based on our requirement, we'll be reaching out to everyone for our issues and concern. If then by this way only we can increase our networking and we can solve our issues. Though everyone is into the same platform, right? Then I'm inviting Aditya when he will be in Pune. Then if he will be visiting my plant, then I'll show him my product and the process. Then I'll be expecting some solution from him.
Definitely.
Yeah, it is a good
Sure.
event.
Thank you.
Thank you. Thanks a
Thank
lot.
you. Thank you, Nirmal. And Nilesh, your quick feedback.
Yes, thanks Manish and Mowito team. It was a good discussion session, and I think for manufacturing industry, this kind of session should be there so that different minds come together and probably discuss what's going on in the market and what is expected and where we can work together. So it will be like a win-win situation for both the parties and learning for everyone. Just
And
one suggestion, if Mojito team would like to, if they won't mind to make here, mm, if you, can I?
yeah,
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 yeah.
yeah.
Please go ahead.
Yeah,
Please.
okay. Yeah. So, in your solutions, if you put something about the process capability or the, when you say inspection, the MSA portion of it, that whatever the sensors or the mechanisms or the camera that you are using, the repeatability and reproducibility of those systems, because that is very crucial and necessary in order to take the decisions and validate this kind of systems transparently. So I am sure, I am very much sure that is put in place, that is already in place in your system. But only if you project them as well, it will be a very positive factor on the good side.
Point noted, Nilesh. Thanks very much for that. Yeah.
Thank you.
Yeah.
Thank you for that, Nilesh. Thank you so much. And Anand?
Yeah, thank you so much for organizing such a wonderful knowledge sharing session. So this is the first session I'm attending through LinkedIn. So I'm very happy to part of it, and thanks to Nirmal San, Bhushan, and Nilesh San for sharing their experience. So it was wonderful experience, and also I will connect with Aditya. So we need 360-degree inspection, automatic inspection mechanism that I will connect with you. And as Nirmal San requested, when you are visiting Pune, you can give me a call so we can have a visit in our plant, and then we can work together. Hopefully, yeah. Thank you, Manisha. Yeah,
Thank
thank
you.
you.
Thank you, Anand. Thank you so much. Aditya, last summary from you in a minute, and then I'll propose vote of thanks.
Yeah, sure. So what were from all the points? I think I'll just make 3 points from what I've gathered so far. I think flexibility beats rigidity. I think that is coming through clearly based on the high mix and low volume kind of production today. But the system still has to give ROI. So nothing takes away from the economics of the system. You cannot do it in any other way. It has to make economic sense to deploy any kind of system, though flexibility has to be a part of it. And lastly, I think the training part is very, very crucial. So operators, starting from top down, everybody has to be in on changing the way things are done. Otherwise, things will not be uh, successful, no matter how hard the management tries. I think everybody has to be in on the system. Yeah, I think these are the key takeaways for me from listening to everybody here.
Any word from Puru?
Aditya spoke my words actually. If flexibility beats rigidity, that's kind of my learning from you.
Yeah.
And we believe in that if you have to provide the consumer a lot of options, and if you have to bring down the iteration cycles or the time to iterate, or bring down the time to give a new product to the customers, you have to be flexible. And of course, ROI is important. So getting a system which is flexible, which is adaptable, and can give the ROI, that is the prime most important thing. And the best part is that, which I learned, was that the AI literacy part, that the operators have to be able, they should be aware about what is the importance of this, what are the different components of this, and as a maker, as the developer of these products, we should be aware how to make operator, how to make it easy for the operator to use it, and how to make it easy for them to adapt to it. Otherwise, if we deploy it and they don't use it, there's no point. Right? So these were the two big learnings for me in this conversations.
Thank you so much. Thank you. And I formally thank all the speakers again, Nirmal, Anand, Nilesh, and Bhushan, who was with us for the first half an hour. And thanks to Mowito team for joining hands together for your partnership to bring the thought leaders, industry thought leaders, and practitioners together to learn from each other. I thank Mowito team again.